This is hopefully going to be the first actual, honest-to-goodness video podcast.
And I'm just Instagramming.
I'm
not even paying attention. I'm Instagramming.
So, this is your host, Brian Evans. With me, as always, is Dan Zisco.
Hi.
You get to see his bright, shining face there, so he looks into the camera, and that's fine. Since this is October 13th. Today is the 13th.
Today is the 13th. Yes, today is October 13th.
This is the day of the Democratic.
I know it's going on in Vegas.
It's happening right now. I
think
at
the
as
Wynn,
we speak.
I believe.
So the Wynn. We don't really like Mr. Wynn because he's an ass. But a lot of people. Yes, he is. He is a complete and utter insufferable ass. Having lived in Las Vegas.
Oh, okay. I have actually heard that he is an insufferable ass.
He is an insufferable ass.
But he did build the Bellagio.
Yes.
And the Wynn and the Encore. So there is something to be said.
So, I mean, I'm not saying that he doesn't know his shit regarding making money in hotel casinos in Las Vegas, unlike Donald Trump.
Here's what gets me. Donald Trump had a rally in Las Vegas, and he didn't even go to his own hotel. Didn't even go to his own hotel.
Because there's
no casino in his hotel. Yep. And the people, and I say this as someone who actually gambles, but the people who are going to support Donald Trump are going to be found near a slot machine. Now, I gamble, but I'm like, you have a hotel. You have your own hotel in Las Vegas.
Yeah. So this time we're going to do probability. And we're going to be talking about gambling, specifically, how probability relates to gambling, because MusingsCon 2015 is coming up. We're going up to Vegas. Hopefully we'll have some fun there. Now, I'm staying at the Aria.
38 days.
You're staying at
the El Cortez downtown.
Cortez, as you always do.
We always do.
I talked to the MGM Aria people to ask them, we're coming to town. I'm doing this thing.
We do this thing.
I have my podcast. I like to talk about, the little details about how things go. And I'm doing a gambling one about this sort of thing. Could you give lessons on how to gamble to all the various people there? Could I come and talk to one of your instructors? And I'm not looking for great things, but just like, what's it like to be in a casino? What does the pit boss do? And all these little things. And they sent me a very nice letter back and saying, yes, we are not going to avail ourselves of this opportunity at this time. So,
but you know what? Nothing ventured, nothing gained.
Yes,
you
asked,
the
worst they could say is no.
Right? Yeah, the worst they could say is no. So you asked, and that's absolutely fine.
So we'll have to see whether or not I might talk to some other casino and see what goes on there. So.
I'm wondering if you actually could send that same email to where I'm staying. They might throw people at you. This is the hotel where I went to not complain, and they're like, just come into the back office and hang out with us for a while. A little bit of a different environment, shall we say.
Probability. And I have my little notes right here.
This is how Brian does this every time.
I do my notes, because notes are good. Notes let me know what the hell I'm going to talk about. They're so much nicer than just having a board where who knows what on earth you're going to talk about while I rearrange a few things here.
I bought, speaking, because you've got a tablet, I did buy a tablet. Well, Rihanna and I bought one of the new 7-inch Fires.
Okay.
It's perfect. It is like the perfect size. It's not as big as yours, but it is a good $50 tablet.
Cool. So, probability. Probability is the science of likelihood. And so, if you have an action that has many possible outcomes, how likely are each of those outcomes to happen?
And
that's the idea of
probability.
Okay. And while gambling is about as old as humanity itself, we can get right down to it, it was only when Blaise Pascal... Yes, that Pascal.
Oh, okay.
From which we have the unit of pressure in scientific bits, the Pascal, which is 1 Newton per square meter. If you went to my old podcast about units, the Pascal is one of them.
Read the notes.
Pierre Fermat of Fermat's last theorem.
Yes.
They were the ones that really codified probability as a science of mathematics and formalized it. Because people had, general ideas of what it is, but they actually dove into the concept of what is probability and how does it work and what do we need to do about it. And simple dice games and tables, they were easy to create. Even Galileo had done some work in that field, but it wasn't really until the 1600s that we really got a science of probability going together. Now, it kind of seems obvious what probability is in the sense of a gambling game. Probability is a huge field regarding that. So it's a good idea to come up with what is probability. So depending upon what you're trying to do, probability can mean a few different things.
Okay.
For instance, first view of probability has to do with frequencies. That is a statistical analysis of the results. You roll a die in a large number of times under similar conditions, and you keep track of the results, and you get, a 1 showed up this many times, and a 2 showed up this many times, and so on. The problem is, what is a large number? Because you want to do enough so that you don't have any
10.
flukes coming through there, but how do you determine what a large number is so that you're not overkilling? So, you can keep on rolling. You never know. Maybe you still have that fluke going on there. And what do you mean by similar conditions? These are things you have to deal with. Is it sufficient to just sort of drop it from a height to, if you're dealing with a coin flip, is it sufficient to just kind of flick it with your thumb into the air and let it land on the ground? Or is there something else that you have to do? Or are all of those things equivalent? So it's kind of hard to determine what is sufficient to be able to deal with it if you're just dealing with a frequency thing. And after all, we know that no process is perfect, no matter what.
No, because we've discussed why that is.
Yes, no matter how many times we throw the die, it's extremely unlikely to get a little circular about it. It's extremely unlikely for the results to always be exactly perfect.
Yes.
For however many times you roll it. So, like Mendel's peas. Do you know Mendel? Do you know about Mendel and his pea plants and evolution and all that?
We started cross-pollinating peas He
was trying to figure out the rules of inheritance, and he had these little pea plants, and he realized, okay, some pea plants grow tall, and some pea plants go short, and some make yellow peas, and some make green peas, and some are all kind of wrinkly, and some are all kind of smooth. And so he did all this little crossbreeding to try and figure out which traits are dominant and which traits are recessive, and et cetera, et cetera. And if you look through his notes, his results are statistically perfect.
Wow. That's not impossible.
So
that's not possible.
He was fudging his data.
But you learn about him in biology, high school biology.
He was right, but he was faking his data is the problem there. So how far away from perfection can we get? Because we know it's never going to be perfect. Before we start to consider the probability to be something other than perfection. That is, how far away from what you would expect can you get before it's like, ooh, something weird is going on.
Yeah.
This coin isn't fair. This dice isn't,
there's something not right.
Not right about what's going on. So, and even then, that assumes that you can even run the experiment a bunch of times. For instance, what's the probability of you buying a house this year?
0.
Well, we could
not 0,
but
because
we can never run that experiment again once it's done, because after this year's over, it's not like we can go back and run through the year again and see if you'd make a different decision based upon putting you in the same conditions. We'll wipe your memory and put you back there. So that gets into what we call the classical interpretation, which is just to assume that all outcomes are equally likely. You count up the number of possibilities, like 6 for die. There are 6 on a standard die. You get a 6-sided die, there's 6. And the probability that each outcome should sum up to 1. Because you rolled the die, you got an outcome, you got something, and each face has an exact 1/6 probability for that. You just assume that, assuming that everything is fair.
Okay.
Now, the problem with that is that the definition is kind of circular. Probability is defined in terms of the equal probability of outcomes, but it assumes that all outcomes are equal. So you need to be able to handle the unequal outcomes. And thus, probability is formalized into a study of how to manage outcomes that aren't necessarily equal.
Okay.
It picks up the fact if all things are equal, that makes the calculations really, really easy.
Very simple.
But if you start dealing with, okay, well, this is a little bit more likely, this is a little bit less likely, despite the fact that you have certain outcomes, it makes it easier. So that kind of gets into set probability now, or set theory, I should say. A set is a collection of things. Okay, so with regard to math, it really doesn't matter what the things are, so especially with regards to probability. So it's just like, we'll call it for a die the outcomes. So for 6-sided die, the set of possible outcomes is 1, 2, 3, 4, 5, 6.
Okay.
Now, given that set, we can break it down into subsets. So the set of even numbers for that would be 2, 4, and 6. And so by comparing the full set of outcomes, we can determine how likely it is to get an item in the subset.
Oh, okay.
So you compare. It's a bit of comparing sizes. It makes it really, really easy to say that if I roll a 6-sided die, there are 3 outcomes in the set of even numbers out of 6 outcomes in the set of the full.
Okay, that makes sense. Yeah, out of all of them. So you have 3.
Therefore, 3 out of 6 that's my probability of getting an even number if I roll the die. So.
Which is 50%, which makes sense. Exactly. Okay, yeah, it all makes sense.
For games like Craps, it's because that's what we're talking about today. We're talking about Craps. This is hopefully going to be possibly a 3-part series here.
Oh, this is awesome! And part 2 will be in Vegas.
Yes, well, depending upon how it depends upon when you're available. So part 1 we're going to be dealing with Craps today. The next one we're going to be dealing with Blackjack. And then the third one will probably be poker.
Will's game.
If we get into the sort of poker. And maybe I was thinking of throwing roulette in there, but roulette is such a simple game to analyze.
Yeah.
So it's really more along the lines of realizing just how bad the odds are at roulette that they're paying you.
Yeah, we won. That's the only game we won on last time we played. Literally.
How did you win at roulette?
Only game anybody won on last time we went was roulette.
Okay. Well, did you play Craps?
No, I have played Craps.
Okay.
I generally lose, not because I don't know what I'm doing, but because I'm like, I'm going to bet everything.
I'm going to teach you at least how to play Craps sanely, because this guy over here, when he plays Blackjack, I have to stand behind him and tell him,
I only do it once.
Don't split your tens.
Sometimes you have to split your tens. Sometimes you have a feeling, Brian.
If you're counting cards, maybe.
You got a feeling. Like, I'm going to do it. I'm going to split my tens. I got a feeling.
So, for games like Craps, it's pretty simple to determine what your outcomes are, because that can be done by what we call a brute force method. And by that I mean you just write down every single possible. You don't abstract it. You don't do sums in the air and stuff like that. You just write everything down. So you can make a little chart. Across the top you have 1 die, and down the other side you have the other die. So you could get a 1 and a 1, and that sums to a 2. And you can get a 1 and a 2, and that sums to 3, and a 1 and a 4. And you just write it all out, and there are 36 possible outcomes, because you got 6 across,
6
down, making sums anywhere from 2 to 12.
Yes.
Okay?
It's like playing Settlers of Catan.
Right. So, I have a little table here, and hopefully I will have a little chart to show what's going on there. That'll be in the video. I can intersplice it in.
It's going to be so cool.
Hopefully it'll all work. So the first column, we have all the 6 possibilities of the first die, and the first row shows all the 6 possibilities of the second die, and you add them up together. But wait, first die. Again, okay, Craps has 2 dice, but which one is the first die? How do we know that one? Well, what we could do is we could color them. We could make like one of them green and one of them red, and as long as we always call the green die, so this is what's on the green die and this is what's on the red die.
And
and it'll work out just fine. They don't have to be the same color, but if they are the same color, you just need to be able to distinguish. This one is always considered first die, and this one is always considered second die. And it really doesn't matter which is which, so long as you're consistent every time you do it. So that's really all that's about. That's how you just arbitrarily make a choice. A lot of stuff is just arbitrary. Now, this is going to change a little bit when we get into poker, because the order of the cards doesn't really matter in poker. Because if I hand you an ace and a jack and a king and a queen and a 10, that's a straight no matter what. No matter how you got it in that order, as well as if I did it ace, king, queen, jack, 10. The order in which poker cards show up doesn't matter. In Craps, it does matter which die is which.
Weird.
In order to determine your probabilities.
Really?
Yes.
Because I'm just all right. I'm gonna let you. Okay. I'm gonna let you finish.
Because the reason why we do that, you'll notice that there are 6 ways to roll a 7.
Yes.
You can get a 1 on the first die and a 6 on the second die, or you can get a 6 on the first die and a 1 on the second die, and those are 2 separate things.
Yes.
Even though you have a 1 and a 6. Those 2 dice are separate, and you need to be able to distinguish between them so that we can determine a 1-6 from a 6-1. So that's why. And then you have 2-5 and 5-2, and then 3-4 and 4-3. And that's why you have 6 different ways of rolling a 7 off of 2 dice.
Yeah.
Compared to 2 and 12, where there's only one way to do it. You can get a 1 and a 1 to get a 2, or a 6 and a 6 to get a 12. So that means there are 36 ways to roll the dice, of which 6 of them are a 7. And so therefore the probability of getting a 7 are 6 out of 36. And since 6 divides into 36, you can reduce that to 1 and 6.
1 and 6.
1 and 6. So now you can then use that table of, okay, well, if these are the probabilities of everything, to figure out the odds for playing craps. So to play craps, the way that craps actually works is you roll the dice. And if it comes up a 7 or an 11, you automatically win. Yay!
And when the point is not on.
Well,
we're going to get to that.
We'll get to terminology at this point, but just the basic concept is you start it. The game has not...
Zero.
This is the very first time that anybody has rolled the dice.
Nobody has ever played craps ever.
Right. So you roll the dice, you get a 7, you get an 11.
Everybody wins.
Well, if you have bet to win,
you win.
Right. If you've placed a pass bet, then you have won.
Because you can also bet
against
the roll.
Right, which is different. If you roll a 2, a 3, or a 12, that's craps, and you automatically lose. That's the first thing. Now, this seems like a pretty good bet. Because if you take a look at the chart, there are 6 ways to roll an 11, or a 7, and there are 2 ways to roll an 11. So that means 8 of those 36 are winning rolls. But there's 1 way to roll a 2, and there's 1 way to roll a 12, and there's only 2 ways to roll a 3. So there are 4 losers. Well, there are 8 ways to win, 4 ways to lose. Hey, this is a great bet. I should take it, right? I have a 2-to-1 chance of winning, right? Well, there's more to that. Now,
but wait.
There's wait. Now, in some sense, if you're reading along in my notes, you'll notice that I've got 8-to-4 odds of winning, and I've changed my phrasing there. I started off with 1 in 6, and now I'm saying 2-to-1 sort of thing. Those are referring to the probabilities. They're phrasing it a little bit different. In the first way, when I say X in Y, I'm setting the number of desired outcomes out of the total possible number 1. So 1 in 6 means there's 1 possibility out of the 6 that I'm hoping for, that I'm getting. Whereas the X2Y refers to the relative percentages of each one of them.
Exactly.
There are 2 ways to this and 1 way to that one.
You are twice as likely to win in your basic math than you are to hit the 2, 3, or 12.
2-to-1 basically means there are 2 ways to win and 1 way to lose. 1 in 6 means there's 1 way to win out of 6 possibilities.
And in this case, it's really 6 out of 36, but we reduce the fraction.
Right. But the point is that in probability, there's lots of ways to say the same thing. You can do this 1 in, you can do the X in Y, you can say X2Y, or you can give a percentage. Because the percentages, when you add them all up, have to equal 1, because 1 is a guaranteed probability. If you have a probability of 1, then it works. So you can do it with percentages as well. So rather than saying 1 in 6, I could say 16.666%, and that's all the same thing. It's just different ways of phrasing it to emphasize what it is that you're talking about. Are you talking about the relationship between the subset to the full set, or are you talking about the relationship of one set to another
set?
So it's
Yeah, no, I got you. I got you.
But they all mean the same thing. Now, this can become a problem when you actually start placing a bet, because you want to win an amount that represents the amount of risk that you took in placing the bet. So suppose I put a bet on the craps table that you'll win winning total on the next toss. What should I win as a reward if I do with that? Because clearly if I bet $1, winning a penny isn't enough.
No.
And winning $100 is way too much for that
awesome.
sort of but it'd be way too much for that. And that's where the odds phrasing of it comes to thing. If I tell you how much you will win if you bet a certain amount for a single toss, if I put up $2, I should win $1 sort of thing. That's because there's only half as many ways to lose as to win. Just on that concept of we're going to ignore any other possibility, just that 7 or 11, 2, 3, 12. There are 8 ways to win, 1 way to lose. So if I put up $2, I should only win $1 back.
So you're going to put up 2
Right.
and you're going to get 3 back.
Right. It's,
Essentially.
total 3
Total
back,
3
but
back.
I will win an extra $1
Yes.
on top of my bet, which I will get back. But if you've ever played craps, you know you put a bet down on the first roll of the dice and it comes up 7 out of 11. You don't win half the amount of your bet. You win the full amount of your bet. You win even money, 1-to-1 odds. Which, wow, I'm getting more back than what I bet. This is a really good deal. Not only do I have twice the number of ways to win as to lose, I'm getting more money back than I really oughta. How on earth does the casino make money off of this? So, that's because
Oh, dear.
there's a lot of other numbers that you can roll other than 2,
2,
3,
3,
12, 7, or 11.
Yes.
So for craps, if you roll a 4, 5, or 6, an 8, 9, or 10, the game changes.
Yep.
Because that first roll is, if you rolled any of those previous numbers, it was an automatic win, automatic loss. If you roll a 4, 5, 6, 8, 9, or 10, the game is now up in the air because you need to roll some dice more. So you have to keep on rolling your dice until you either roll the same number again, and that's called your point. When you rolled your 4, 5, 6, 8, 9, or 10, that's called your point. And now you need to keep on rolling the dice until you either roll that number again. Who on earth is calling me at this time? So at this point, I'm going to actually just has yeah. See, this is what happens when I record inside my own home and don't turn off my damn phone. And this is the landline, and who on earth is calling me at this hour? So this may get edited out. We may continue on there. So you roll your 4, 5, or 6, 8, 9, or 10, and you get a point. And now you have to keep on rolling dice
Until you get that number again.
until you either get that number again or you roll a 7. If you get the number again, yay, you won. If you rolled a 7, you lost. That's the way that it works. And any other number doesn't matter. So if my first roll was an 8 and I roll the dice again and I get a 10, that's neither a win nor a lose, and I keep on, and I roll the dice again. And if I rolled a 6, well, it's still not an 8, nor is it a 7.
And you just
so I
keep
keep
rolling.
and rolling and rolling and rolling in order to get either that. Now, as we noticed previously, a 7 is the most likely number to roll. So the odds are no longer in my favor.
Exactly.
On the first roll, the odds are in my favor. But if I have to keep rolling, the odds have switched to the house's favor, which is where the casino makes its money. So you are more likely to roll 7, crap out,
than anything
as it's
else.
often called, than you are to hit your point again. So what that means is, for my original bet, when there were 8 ways to win and 4 ways to lose, well, now I have all these other numbers that I need to sort of add into that. If I roll a 4, sometimes I'll win, and sometimes I'll lose. And what I need to determine is, if I roll a 4, how likely am I to roll a 4 again before I roll a 7 again, and parcel out that division to the win parts onto the win side and the losing parts onto the losing side in order to determine what my probability is and what my actual bet should be for it is that I'm getting there. So, there we go. Now, so if you take a look at our chart again, 3 ways to roll a 4 compared to 6 ways to roll a 7. So if I roll a 4, the odds are 3 to 6 against me. Okay? There are also 3 ways to roll a 10. So the odds are the same thing. So for the 4 and the 10, they have the same odds on both sides. And you continuing this on for 5 and 9, there are 4 to 6. Again, there are 4 ways to roll a 5 or a 9 compared to 6 ways to roll a 7. And there are 5 ways to roll a 6 or an 8 compared to 6 ways to deal with that. So, but look at what it is that we've just done. We've just listed out our possible outcomes and determined if they're a winner or a loser. We've got 3 to 4, or 3 to 6, 4 to 6, 5 to 6. Twice, because they're on this 4, 5, 6, and 8, 9, 10. So the way you can do that, so what we've done there, to figure out the probability of winning, to roll a 4, all you have to do is multiply those together. There are 3 ways out of 36. It's going to affect the odds by 3/36 of the thing. So if you roll a 4, your odds of winning are 3/36, and your odds of losing are 6/36. So you would add to the winning side 3/36 percentage, or fraction.
Fraction.
And then on the losing side, you would add 6 36. And you do that for each one. And you'll notice that rather than being 2 to 1, they start to even out.
Yeah.
There. So that brings up the third way of expressing things, the fractions, which I had talked about before. So you can derive that from the other two. If you take the number of winning ways and divide it by the total number of ways to get an outcome, that's your percentage chance. 1 over 6, 16.66%. The other way to do it, if I tell you 2 to 1, then you would add those numbers together because that's your total, and then take your number divided. So 2 to 1 would be 2/3 on one side and 1/3
on the other.
So all you need to do then is start multiplying these numbers together to figure out what it is that's going on. So if you have a point of 4
in your head with cocktails and
I
people screaming at you.
Yes.
So just remember that.
So if you have a point of 4,
okay. So you've rolled the dice.
Yes, right. You
The
roll a
point
4.
has gone on to
Right.
4, which means
There's
you have to roll a 4 again before you roll a 7.
But the chances of a 4 showing up at all is 3 out of 36. And your chances of losing if you've rolled a 4,
Wouldn't it be 4 out of 36?
there's
Oh no,
yeah.
because it's 1 and what? It's 3 and 1, 1 and 3, and 2 and 2.
Right.
That's your 3. There's only 3
ways-
possibilities.
There's only 3 ways to roll a 4. So the chances of a 4 showing up in the first place is 3 out of 36, or 3/36.
Mm-hmm.
And the chances of you losing are 3/9, because there are 3 ways to win and 6 ways to lose. So 9 ways total that the game will end, because all the other numbers don't
matter.
count.
Yes.
So you multiply those together, 3/36 and 3/9, and you have a total loss.
The 9 ways to lose comes from the 6 ways to lose comes from the 7.
Right.
Okay.
Right.
So that makes sense.
Right.
So there are 3 possible outcomes that'll give you a 4. There's 6 possible outcomes that'll give you a 7. The total possible outcomes are 9 because nothing matters.
Because nothing else matters. Only 4 and 7 matter at this point
At this point in the game, and then you multiply those together.
So you multiply 3/36 by 3/9, and that's your chance of losing, which for 4 is 1/36. And you would add that to the losing side of the column. And similarly for 10. Now for a 5, you've got 4/36 chance of that appearing. There are 4 ways to roll a 5 and 36 ways to roll the dice in general. And your chances of losing are 4 and 10.
Because it's the 4 plus the 6 makes the 10.
Right, so there are 4 out of 10. So you multiply those together and you get 2/45. And I have this wonderful little chart, and you get it together. And thus, for 6 and 8, it's 25 out of 396 and blah, blah, blah. And you add all of those fractions up, and you get a number 134 over 495. 134 495ths. And when you add the 8/36th chance of rolling a 7 or 11 on the first roll, you have a 244 out of 495% chance or fraction of winning.
Did you do the percentage?
Yeah, I said percentage, but
did you
yes.
do the percentage?
Yes,
okay,
I have.
So I don't actually have to figure it out.
244 divided by 495 is just under
49.29%.
Yes, it's just under 50% by about 0.7%.
Yeah, it's about right.
It's about 0.7-ish. So that means the house is cheating you.
Yeah, it's less than a percent
Yes.
in the house's favor, but
Yes.
it's still in their favor.
Because when you win in craps, they just pay you even money. You bet $1, you get $1. But your risk was slightly worse than just 1-to-1. So rather than getting $1 back, you should be getting $1 and a penny. But they don't carry pennies, and they're not going to give you a penny. And besides, the house needs to make their money somehow.
Yeah,
and so they keep that money.
But on thousands of rolls every day, on
Yeah.
thousands of bets
Yes.
every day,
Yes.
those pennies add up.
That's how the casino makes their money.
The accountant brain is like, all right, let's do it. Like, those pennies all become something.
Yes. That's how the casino's got to make their money somehow. Now, and so what I have right here, and the same way on the other side. So rather than paying you even money, you should be betting 200. You should be getting 251 to 244. If you put down a bet of $244, you should get $251 back.
You should win You should win $3 on.
Well, you should win the $7.
The $7. Oh yes,
Right.
it's not $3. It's $7.
And so, like I said,
thinking
that's how
$3 from earlier.
they're not paying you true odds. Now, this can be seen across a whole bunch of other bets that are on the table on craps. So, for instance, there's a place called, rolling an 8 the hard way. And what that means is you roll the dice and you're betting that it's going to total 8, and it's going to total 8 by rolling a 4 and a 4 specifically, because there's only one way to do that.
And that's very hard. I don't know if that's what that means, but
compared to, well, it's because it's the hard way.
It's the hardest way, yes.
There are other ways to get an 8. You can get a 2-6, you can get a 3-5, and there are 4 ways of doing that compared to one way of getting an 8 specifically as a 4-4.
1 out of 36.
The hard way.
Yes.
So you're rolling an 8 the hard way. So, since there's only one way to roll a 4-4, and there are 6 ways to roll a 7, and 4 ways to roll an 8 and some other way, there are 11 outcomes, of which 1 is a winner and 10 are a loser. Either because you didn't roll it the right way, or you rolled a 7 and you crapped out.
Because, again,
it's 7,
nothing else matters.
It's nothing else. Thus, fair odds would be to win 10 for betting 1. But you'll actually only get 9.
You're gonna lose
again because you're gonna. But wait, I hear some of you cry. I'm looking at the table. I'm looking at this craps table right now, and it says 10 for 1. Why am I only getting 9? Because notice what they said there. They didn't say 10 to 1. They said 10 for 1. FOR 4.
So what's going to happen is you'll put your 1,
right.
You'll roll your 2 4s. They will take that 1 away, and they will give you 2 5s.
They will give you a 10, or depending upon
the casino. If
they're trying to color you up.
Whatever it is, they're going to take that 1 away. You don't get that back, and they'll give you a 10. Right. You feel like you've won $10.
There's a little.
You've only won 9.
You've only won 9. Now here's a little thing. It's called coloring up. When
I excel at coloring up.
Yes. When you are betting, suppose you are at a table.
Don't ask guys.
And the limit is it's a $5 lower limit on the thing. So you have a whole bunch of $5 chips, and you've been betting and you've been betting and you've been betting, and you might have gotten something back where your bet back is coming back as 25. So rather than giving you 5 chips, they will give you a $25 chip, in the hopes that you will eventually collect enough of these $25 chips that instead of betting the $5 chips,
you start betting the $25.
You start betting the $25 chips. It's called coloring up. It's, in some sense, a little sneaky thing that casinos do to try and get more money out of you. Depending upon the dealer, it'll be a good thing, bad thing, etc., that sort of stuff. A lot of casinos, they don't really... It's I wouldn't say they encourage it or anything, but it all depends upon how good your dealer is and whether or not your dealer likes you and wants to keep you around and keep you playing, etc. Because if you start coloring up, you're going to start losing your money even faster, and then you're no longer playing, and that's bad.
Yeah.
So it's iffy as to whether or not they're going to do that. So back to that. So you bet $1 there. So when the table says 10 for 1, we figure that out. So if you take a look at the other bets on that table, you'll see that their odds are just as bad. Oh my God. If you throw... So it's really, really bad to deal with that. They're just things like rolling a 6 or an 8 the hard way. The big 6, the big 8.
Those
the
are
field.
terrible.
I'm going to play the field. There's all these other little things. Because it's not so much that it's a bad bet in and of itself. It's that they are not giving you fair odds for the bets that you are taking. If they were giving you fair odds, then it doesn't really matter whether or not you take the bet, because over the long haul, you would come out exactly even. Mm-hmm. If there's a 2-to-1 bet, okay, well, that means there are 2 ways to lose and 1 way to win. And so I have 3 units, and I bet 1 on the first time and it loses. And I bet a 1 for the second way and it loses. And I bet a 1 on the third one and it pays out 2-to-1. Well, I now have 3. I started with 3. I lost 3 and got 3 back, so I'm exactly where I was at the start of things. So if it's fair odds, that's fine. But the casino is not giving you fair odds. But wait, in craps, there is. Craps has the only fair bet in the entire casino.
And I know what you're going to say, yes.
It is not on that first roll.
Mm-mm.
It's on the second roll. It's called taking odds.
Yep.
And the way that works is that if you don't roll a 7 or a 10 and you don't roll a 2, 3, or 12, you get a point.
The point goes on.
4, 5, 6. 8, 9, 10. You can then make a second bet that you are saying, I am going to win this. I know I put a bet down to begin with, saying that I was going to win just in general, but I rolled a 6, and now I'm going to make a second bet that says, I am specifically going to roll a 6 before I roll a 7.
Yes.
And that bet, that's called taking odds, the casino pays off on that with true odds.
It's true odds.
True odds on that. And because of that, it actually reduces the house's edge if you take that bet.
Over the long haul, too.
Over the long haul. So,
which I always take that bet.
You always have to take that.
Because it is good odds. I mean, it's the best odds you're going to get in a casino.
So suppose your point is 4.
Okay.
Okay. So there are 3 ways to roll a 4 and 6 ways to roll a 7. Thus, the odds are 6-3 against you. Which is the same as a 2-1. So for your pass bet, if you roll a 4 before rolling a 7, you're only going to get paid 1-1. But for your odds bet, you're going to get paid 2-1.
Mm-hmm.
So, and that's, like I said, it's the only fair bet in the entire casino. And because of that, craps is one of the best games to play in the casino, since you can make... now, granted, the house edge for craps is pretty dinky to begin with for plain stuff. Not all the other really bad bets, but for the straight plain game of craps, the house's percentage is tiny. It's 1.4%.
That's nothing.
Which is hardly anything. It's technically better than blackjack, just played straight without any card counting. So that's craps is really good, but with the odds bet, you can reduce it even more.
Yeah.
So the way you deal with that, the way to play craps is, first, you place a bet using a multiple of 3. Whatever the unit is, you need to link it. So if your base chip is $1, you're going to be playing $3, or if your base chip is 5, you're going to be playing $15.
You've got to do it.
And the reason that you do this is because we're talking about single odds, a single odds craps table, and I'll explain what that means in a brief moment. So you make your pass bet, which is basically the bet at the start of the thing that says, I think I'm going to win. I'm going to put my bet down, and I think I'm going to win. I'm either going to roll a 7 or 11, or I'm either going to make a point and then I'm going to roll a point and then make the point.
Because as we discussed before,
right.
The 7 or the 11 is going to come up way more than anything else.
So
that's a good bet.
Right. But that's just the general bet, is that I am going to win, either by winning outright or by making a point and then making the point again.
Yes.
So once I do that, if I roll a 7 or 11, yay, I won. I take my winnings. Again, put a pass line down. If I roll a 2, 3, or 12, ooh, I lost. Lose my bet.
But again,
I put a pass line bet.
Yes.
You put a pass line bet down. This time, I don't roll 7 or 11, and I don't roll craps. I roll a point. So now I put the odds bet down, and this is why you wanted to do it in sets of 3, because for straight single odds, since they're going to be paying you the actual amount, if you do it in sets of 3, because the problem is when you start dealing for 4 and 10, it's really easy, 2-1. Whatever it is they put down, they're just going to double it and give it back to you. But for 5 and 8, it's not 2-1. I have it here in my notes there. So it's for 6. That's on a 6 point. The odds are 6-5. And 2 doesn't divide into 5 very well. If you put down 2, you don't really divide it there. So if you had bet $5, you'd win 6. But 2 is 40% of 5. So if you bet $2, you'd get back $2.40. And no casino has 40 cents just sitting around. They don't have coins around there. So what they will do is they'll let you increase your odds bet on those numbers that are weird, like 6, 8, 5, and 9. Mm-hmm. So that's why you do it in 3. So that when if you do it on the 4, you can put down 3 chips, because you started with 3, you put down 3, and they will give you 6 back. On the next one, you put down 4. Even though your original bet was 3, you're going to fudge it a little and put down a little bit more and give you 4, because the odds are 4-6. And if you win, they will give you 6 back. And similarly for the 6 and
put down
8,
five.
you put down 5 chips because, again, the odds are 5 to
6.
6. And so therefore, they let you increase your bet a little bit more so that they can give you a nice amount of money to give you for that. So that's why they're doing that, because 5 and 9 is 3 to 2, 6 to 5, etc. Now, there are some casinos that increase that even more.
Yes.
They will have double odds, 10 times odds. There are even some craps tables that will have 100 times odds on those odds bets. If you can afford it, take it. Because, again, this is the only fair bet in the casino. And because it's fair, in the long run, it doesn't matter if you're winning or losing because you will come out even. You'll come out even. And if you get on a good streak such that you are very far ahead on a $5 bet, or if you're doing because you're doing it in units of 3, on a $15 bet, if you can put down $1,500 as your 100 times odds bet and it comes up, congratulations, you just made a buttload of money on that bet.
Yeah.
So, and at that point you can say, yep, I'm cashing out.
See you later.
I just paid for my room and that sort of thing, and you can get out of there really, really fast. In fact, when you take 100 times odds bets, the house edge goes down to like 0.0006%. It's tiny, minuscule, small. It's still in the house's favor.
Everything
because there are still more ways to roll a 7 than there are to roll the other numbers. But because they're paying you fair odds on this amount of money, let me get that in there. Fair amount of odds on this amount of money compared to the house advantage on that amount of money, it comes out in your favor. Or at least more accurately, it comes out more closer to being fair odds, even odds on that sort of thing. So that's what it is that you want to do. Now, so you do that for the first roll. You put down a point, and then you make an odds bet on top of that. Do you just sit there and do nothing? No.
You can.
You can.
It's boring.
You can, but you shouldn't. You should continue on and keep going. So now what you make is what's called a come bet. And if you look at the table, you notice there's a great big thing there that says come on it. C-O-M-E, don't. As Archer might say, freezing!
Freezing. Nicely done.
Nicely done. So you've set up your pass bet and you put down odds. And so what the come bet is it essentially starts everything over again. Because the pass line, you've rolled a point, and now the game has changed to we're rolling to see whether or not you're going to hit your point or you're going to hit a 7. What the come bet does is say, let's pretend that we're starting from scratch. I want this, whatever dice rolls up next. If it comes up 7 or 11, great, I win my come bet. If it's 7 or 11, I will lose my pass bet, but I will win my come bet.
So you're always got
so
something
going on there.
Yeah, you're always winning.
But
possibly.
then but if that comes up a point, you again place odds on that point.
The money moves to the point.
Goes to the point
and
just as before, and you put your things on there. Okay, so now you've done that twice. So here's an example. So suppose you put a pass bet down of 3, and you roll a 10, and thus you put an odds bet down of 3 on top of that, because that's what you've got. So if you leave it at that, and your next roll is if you roll a 7 next, you've lost 6, you're down. But if you would put a come bet down of 3, you would win 3 as well. So rather than being down 6, you're only down 3.
Yeah.
So that's why you do that. But suppose the second roll is also another one of those points. It's not a 10 because that would have been a winner. But now suppose you've got... so what you want to do, you want to take down that point and then put odds on that one. So the first roll is a 4 and the second roll is a 10. Well, now you have 4 and 10 in play, which means because there are 3 ways to roll a 4 and 3 ways to roll a 10 and 3 ways to, or that's 6 ways.
And 6 ways to roll a 7.
You are now at parity. You are likely to win at least one of those bets. Before or you are just as likely to win one of the bets as you are to lose outright, which is why you want to take that second bet, because now it's more likely for you to actually win something, that sort of thing. So, is that enough? No. you want to do it yet a third time. You want
Put
to do it a
something on
third
the
time.
cum bar
so
again.
you put down another cum line bet, and that goes through. You now have 3 numbers in play. Now at that point, it becomes a bit dangerous to keep going. You want 3 is pretty much the limit, because if you put down a 4th bet, because a 7 is much more likely to happen, you are more likely to lose your cum bets and your pass bet than you are for that one to deal with that. The chances of rolling not 7 4 times in a row is much less than rolling a 7, if that makes sense.
Yeah,
Because
no, of course.
there's lots, because there's 3, 4, 5 and 5, 4, 3. So that's 10, 18, 24 ways to roll a not 7 and not crap out. Or not 7, not 11. There's 24 ways to do with that. So if you want to cover as much of that as possible without making, but it's difficult to do that so many times in a row.
Mm-hmm.
That sort of thing. So that's the reason why.
So basically, pass bet, point, bet moves, odds,
Right.
cum line, roll. It goes to say the other one, odds.
Okay,
If you
so-
do it the third time,
Yeah.
stop.
Well, you need, yes, once you hit your third one. So let's calculate. Calculate what are the odds of not rolling a 7
I knew
4
this was coming
times
up.
in a row.
I
We
knew
got to
this
be
was-
able to do that.
Yeah.
So what you do that by calculating the probability of not rolling a 7 and then multiplying it 4 times against itself 4 times, because each roll is independent.
Yes.
Okay? So you want to determine how many ways of not rolling a 7 on the first row, and then for each of those ways, you want to determine how many ways of not rolling a 7 on the second roll. And then for each of those ways, you're finding out how many ways to not roll a 7 on the third roll, and then do that same thing again for the fourth one. So that means we have 6 ways to roll a 7 and 30 ways to not roll a 7, because we are including the craps bits on that. So the probability is 30 out of 36.
Yeah, that makes sense.
To not
Okay.
roll a 7. So that means for each of those 30 ways of not rolling a 7 on the first roll, there are 30 ways out of 36 to not roll a 7 on the second roll.
And the third roll.
And then for that one, you've got 30. So that's 30 over 36 squared. Okay? And you keep that up for 4 rolls. That's 30 over 36 to the 4th power, which is 48%. It's just under 50% to deal with that. And that's why you say after that 4th roll it's right around 50-50, but it's right around 50-50 against you.
We're tipping to the other side.
To the other
Yeah.
side. So if you're feeling lucky, go ahead and take that 4th one.
Because
But
sometimes
odds-
you have a feeling, Brian.
Yeah, and that feeling is don't split your chins. That feeling is me hitting you on the back of the head going, what the hell are you doing?
Sometimes you have a feeling.
And stop it. So for 3 in a row, it's about 57.9% that you will be able to do that. That
Okay.
you will be able to get 3 non-7s in a row.
And that's like, I would take 57% when I've got money on the table at a 4 and 10 because you're at parity, as
Right.
you said. So that's fine.
Yeah. So now there's another way to play, and that's to bet against the shooter, because the way that we've been describing it is that you are betting that the shooter is going to win. That when they roll out that first set of dice, they are going to hit 7-11, or not crap out. And if they get a point, they are going to make their point. The other way to play is the exact opposite. I think the shooter's going to lose. That first roll is going to be a 2, 3, or 12, or they're going to hit a point and they're not going to make it. The odds are slightly better to bet against
the shooter.
than it is. And I can really go into that. The problem is the difference between the two is outrageously small. It's about 0.05%.
So, yeah.
Is the difference between the two of them. And when you, because it's not the house's odds.
This is the don't pass line?
This is the don't pass
Yeah,
line.
because there's
and
a
the
pass-
don't come line. There's a
pass line
and
and
a
a
don't
don't
pass
pass.
line. And you'll notice that on the craps field, the pass line is this big. The don't pass line is that big.
'Cause people don't-
And the come line is that big, and the don't come line is
because
that
people
big.
generally don't bet against the shooter. Some people do.
Right. Some people do. It's called wrong betting because you're betting against the thing. And when you do that, everybody hates you because, damn it, you're betting against me. And how dare you?
And
sort of thing,
craps
something
is
like
a
that.
fun
It's
communal
it's a social
game. It's a social
game that they deal with that. And, blowing the dice and we'll roll it there, etc. thing. So The difference between the two is so small that you would need to be playing quite a lot to even notice. I was doing my research on this to be able to get my notes, and I'm reading up on someone who pointed out that if you had spent something like, it was like 16 hours a day playing craps with an average of so many rolls per hour, that's how long you would have to play to see any real noticeable difference
in
between
playing
the amount you would have won compared to, or I should say, the amount you're losing compared to what you were losing
that
before.
Just doesn't seem worth it.
Yeah, it's just
it
not
doesn't seem worth
it. And the way you calculate is a little bit different, and the strategy is a little bit different for playing against. This way is just a very simple. It works. It's a good strategy. You don't do any of the stupid bets. You make a pass bet. You lay down odds. You lay down as much odds as the table allows. If they're playing single odds, that means 3, 4, 5. For the outside ones,
outside going in,
it's 3 chips, 4 chips, 5 chips, because you're doing it on bets of 3. If they're playing double odds, you double that amount. If it's 5 times odds, 10 times odds, 100 times, whatever it is that you can afford, bet as much as you possibly can, because otherwise you're leaving money on the table.
And I think a lot of people do that. I think especially downtown, you'll see cheap craps with huge odds or bigger odds, but it's a type of gambler that can't necessarily afford that, and so they are leaving money on the table. And by leaving money on the table, you're giving money to the casino. In a sense.
In a sense, you're dealing with that. But that's the problem about craps, and why it's a somewhat difficult thing, because you need to have a good bankroll to survive some bad runs of dice.
Because that'll happen.
Because even just normally, suppose you're playing normal craps, so you put down a bet of 3, and suppose you get a 6. Which means you need to put down 5 on top of that for your odds bet.
So now you're at 8.
So now you're at 8, and then you do it again. You put your 3 on your come line, and suppose that comes out as an 8.
So then you're at 11.
Another 5 on top of that, so you have another 8. So now you have 16 of your units on that, and you put down your third bet, and suppose it comes down as a 5, which is 7 on top of that. So you have 8 and 8 and 7. So that's 23 units. And if you're playing at a $5 table, that's $115 that you have sitting on the table.
That can all go away in a 7.
And if someone rolls a 7, it's all gone. Now, if you hit a few, you're up. You're up a lot. And so every time
and you're up a lot fast.
And you can be up a lot very, very fast. And so if you make your points and you get them, you just keep up. So for instance, my pass was a 6, and I have come on 8.
And you giggled!
I giggled. So my pass is a 6, and I got come on 5 and 8. If I make an 8, I take my winnings and I put another come bet down so that I always have 3 in play. So that's why you can easily start raking in money very, very, very fast. But then a 7 comes up and it wipes it all out, and you've lost all the money that you have out on the thing. So if you're going to be playing craps, if on a $5 table, you need to have a bankroll somewhere around $500 to start off with, just to play for a while, because you can easily lose a quarter of it right off the bat.
Yeah, I mean,
because you got some bad dice.
Our friend Jeff, and you met Jeff at our Christmas party. We all went to Vegas for Billy's bachelor party, and we told this story thousands of times. But one thing that we don't mention is he got it from the blackjack table and decided to go play some craps. And he started with a decent bankroll, a few $100s, but when he came back, it was like a stack of black chips.
Yep.
And if you don't know what black chips are, those are hundreds.
Hundreds, yeah.
And he made about $1,000 in about an hour and a half. He started with a big bankroll. I mean, he probably started with $500,
yep.
But he walked away with $1,500 because that can happen. You get up very
fast. It's the flip side of it. If you get a good roll of dice, suddenly, oh my God, you're swimming in money, because they're paying straight odds. They are paying not legal odds. They are paying fair odds.
Fair odds.
The true odds are at the craps table.
Yeah. Well, and the funny thing about that is that of that $500 could have been gone in 25 minutes. Just like that,
yeah.
And I've actually lost $100 at a craps table in 10 minutes.
Yep.
Because I literally walked in a 7, 4, 7, 4, 10, 7. It's like, God damn it. But that happens.
It happens. So that's craps. That's the basics of craps and why you're going to deal with it. Now, with this, you can sort of take a look at the other bets that are in craps to determine whether or not you're willing to take the crappy odds that they are giving you at craps for these things. Because there, like I said, there's other bets. You can play the field. You can buy numbers. That is, rather than leaving it to the luck of the dice to say, oh, the point is 6, you can come on and say, no, I want to buy 6. I'm betting that a 6 is going to come up before a 7. And then I'm going to lay odds. It's called laying odds when you buy the number. And do with that. It's not as good because you're not dealing with the probability of the dice doing their work for you. You're sort of overriding the dice, and so therefore the odds that they pay you back are not quite the same, and therefore it's not as good. But there's other things, playing the field, etc. So there's all sorts of things. Take a look at that chart. That will tell you what are the odds of each number coming up. You can then determine there are so many ways to get a winning result out of so many ways to get a losing result. That'll tell me what my odds are, and that'll tell me what I should win for whatever it is that I bet. And then you can compare what the casino is actually going to give you compared to what they should be giving you, and then you determine whether or not you're up to that. And that's kind of roulette. We're not. If we do roulette, that'll be with the poker thing, because roulette is very, very simple.
It's a very simple game.
But roulette, really, that's all that roulette is that there are 38 numbers out there,
and yes.
And so therefore, when you bet a single number, it pays not 38 to 1,
36 to 1.
It's 35 to 1.
35 to 1. That's
35
right. Because
to 1.
You get 36 back.
Right. So it's 35 to 1, and so you're losing 3 off of your odds there. So, but roulette is all about it works exactly the same way. Here's the ways to win, here's the ways to lose, here's what my odds ought to be, and they're not paying me that. So that's craps. Hopefully the next time we are going to be covering blackjack. Oh god, blackjack is complicated. Blackjack, it seems like such a simple game.
It's not.
But it's not. It's if
I have a great story when we do it.
Yeah.
And if Billy's around, he will share it with you about Billy. And then I'll go into more detail. But at one point because there's a variant of blackjack that we play that's no longer at the El Cortez called double attack blackjack.
Yeah.
I don't tell you.
We
can talk about why that's a weird
variants on blackjack out there.
But we're driving out, and I hear Billy under his breath going 2, 3, 4, 7, 9, 4, 6, 9, and I'm like, what are you doing? He's like, because he had memorized the strategy for double attack.
Yeah.
And he's just running through the numbers, and because with blackjack there's a whole strategy and the odds and what you do on what. Right. But just the idea that somebody memorized it was and then double attack was gone, so we made fun of him all weekend. It was great. All right, there you go.
So there we go. That's our show today. We're dealing with craps. Hopefully the next one about blackjack will happen before we go off to.
It's quite possible
because we have a whole month that we can.
38 days.
38 days to do yet another recording on.
I will be in Ohio for a week. I might be on History of Bad Ideas if we can get it all together. But
you're shaking the table.
I'm sorry. I do that. But in between the time I come back and we all go, we should be able to do this.
Hopefully.
That would be fun.
All right. So we are on the Musings of Geek Podcast Network. There are an infinite number of podcasts on there. So do you know all of your podcasts?
No, because I broke them all out, because I actually broke out because some of them stopped updating with me or in general, so I've just kind of moved them to classic musings. But
kind of like, what are you into?
Yeah,
it's
exactly
one episode.
It's in episode. But we've got pop culture analysis. Yeah. We've got comics and video games. We've got movies. We've just got comedy podcasts. There's a Doctor Who podcast. Yeah, which they haven't updated in a while.
And the new season just came out.
I know.
Have you been watching
yes, I have, and I love it. I love Capaldi. I'm not crazy about the Sonic sunglasses, but we can.
I knew about the Sonic sunglasses before it is because I've been playing the Doctor Who app. The little ball matching game that they have for that, and it's like, what, Sonic sunglasses? That's an item? So yep, it's Sonic sunglasses.
It's Sonic sunglasses, but it's been a good season so far.
So yeah, we've got here, now that I have the website up here, we've got Musings of a Geek, History of Bad Ideas, Lucky 10,000. Who are they?
They're on the Bearded Ones podcast network.
Yep. Pittsburgh Nerd Pod, Red Horse Radio, Sons of the Renaissance.
Which are not they're not a podcast about the Renaissance, and Billy was very upset. Very upset.
Sweating the Small Stuff, which you're listening to right now, and Who the What Now. We've got Movies and TV with 365 Flicks, Arrow of Time podcast, The Comic Roast presents The Movie Roast, And pilots. Have you done a pilot?
We haven't done a pilots in
a
forever. It's been a long time since we did
Good.
pilots.
What is your next pilots?
I have no idea. I would love to do a pilots because I don't have to put together a show that week.
Well, Supergirl is coming up.
I would
We could
do
do Supergirl.
every time I suggest one, Des says no.
Well, that's because he
No.
doesn't like anything. Well, it's a DC, and we all know what he thinks about DC, so there's that. So, Comic Roast, Graphic Novice, Green Up Podcast, My Comic Shop History, 40 going on 14, Bearded Ones Podcast, Dark Angels and Pretty Freaks Podcast, which I think I still have their little swag thing. that
They
found
sent some
around
swag.
Somewhere. Here it is.
Brian found
There
it.
it is. My Dark Angels
Dark
and
Angels and
Pretty
Pretty
Freaks. My little cozy here that we got for it. So there's that. Salty Language Podcast, Vice Podcast, The War Pod, and then of course the Classic Musings.
There's a bunch of
There's
them.
a whole bunch of them, Arkham, stuff like that. Hopefully they will be able to get back together. But thank you very much for watching this. Hopefully this will not be just an audio podcast. I will indeed
would
have
be
recorded down
amazing.
the video
That
thing.
would
It'll
be
be really, really
amazing.
great. It'll be so amazing that we can put it together. But if not, we'll be doing this again.
Yes.
We'll record it again. And thank you for watching. This is Sweating the Small Stuff with Brian Evans, where the devil's in the details.